Okay, so let's graph the tangent function. So I pulled up a unit circle over here to the side, so we kind of have those points in front of us. So let's start with tangent of 0. So tangent of theta, remember, is y over x. So at 0, it would be 0 over 1. So tangent of theta is the y coordinate over the x coordinate. So this would be 0. Okay, then if we go tangent of, we're going to go pi over 6. So that's 0. This is pi over 6. So tangent of pi over 6 would be 1/2 divided by root 3 over 2. So that's 1 divided by root 3. If you rationalize, it's root 3 over 3. But either way, it's approximately 0.577. Okay, and then tangent of pi over 4, well, root 2 over 2 over root 2 over 2, that's going to be 1. Okay, then tangent of pi over 3 is going to be root 3 over 2 all over 1/2. So this simplifies to square root of 3. And then we get up to tangent of pi over 2. Okay, so we'd have 1 over 0. Well, that is going to be undefined. Okay, so let's plot the points that we've gotten so far out of the first quadrant. So 0 is 0. Pi over 6, okay, each tick mark is pi over 3. So pi over 6 is between 0 and pi over 3. Pi over 3 is at about this root 3, pi over 3 is at about a 1.732. Okay, so a little bit above a 1.5. So pi over 3, a little bit above 1.5. I guess I skipped pi over 4. Well, pi over 4 is going to be between pi over 6 and pi over 3, and that's about 1. Okay, we did pi over 3 is about the 1.7. And then at pi over 2, you are undefined. So right here, if you're undefined, that's where you're going to have a vertical asymptote. Okay, so what happens with tangent is there's also a vertical asymptote at negative pi over 2. And then if you go to the negative, we could do a negative pi over 6, a negative pi over 3, and so on. You're going to get points that are down here, and then they come up and do that. Okay, so some points that could be of interest to us are, another point would be at pi. Okay, so if you look at pi, the ordered pair is -1, 0. So for tangent, the y value divided by the x value is 0 divided by -1, which is 0. So at pi, tangent's at 0 again. So what's going to happen as you plot more points going around this unit circle is you're going to find that at every pi units, or there's a span of pi units in between asymptotes. So there's an asymptote here at pi over 2. There's going to be an asymptote at 3 pi over 2. There's going to be another asymptote at 5 pi over 2. And your tangent crosses at every pi. So it has an x-intercept at pi, at 2 pi, at 3 pi, at 4 pi, and then so on. And then in the middle, between those, at every half of a pi, then you have vertical asymptotes. So again, I mean, you can go through plot points, but this is what your tangent curve is going to look like. So at every pi intervals, you have an x-intercept. And then at the halves, 1.5 pi, 2.5 pi, 3.5 pi, so on, you have vertical asymptotes. I can follow the pattern. I can go the other direction, but same thing is going to happen, and that's your tangent function. Okay, so a couple of things to know about your tangent function is, let's talk about amplitude. Oh no, that's not what I want to do. Okay, let's go back here. Tangent doesn't have amplitude because it goes to positive infinity and negative infinity. So amplitude isn't really a conversation that happens when you're talking about a tangent function. Now you can change the A. Now in sine and cosine, that makes a big difference because it's tells you how high. Okay, it does have to do with the height, but on tangent, you can have a value there for A, but it just kind of stretches them up faster, if that kind of makes sense. You just won't see as much of a curve there in the middle as you do right now as your A increases. Okay, so the main thing you need is to be able to find where the asymptotes are. Okay, so your period for a tangent function is pi. Generally speaking, is pi. Well, it'll be pi divided by b. Okay, just like you do with sine and cosine. So if something's in front of your variable, then that can change the period. Okay, then to find your asymptotes, you want b theta minus c to equal negative pi over 2, and b times theta minus c equals positive pi over 2. So what this does is gives you two consecutive asymptotes. So if you know where two asymptotes are that are next to each other, then you can just repeat that spacing and find where the next asymptote is, the next asymptote, the next asymptote. And then tangent's going to cross the x-axis right between those two asymptotes. D still gives you a vertical shift, and C gives you a horizontal shift. So those are going to stay the same. Okay, so you can manipulate them the same way you can sine and cosine. Okay, with cotangent, kind of the reverse happens. So you know that cotangent is the reciprocal of tangent. So for example, everywhere that tangent is 0, okay, you can think of that as 0 over 1. Well, if you flip 0 over 1, okay, let me just show you. Okay, so the tangent of 0 is 0 over 1. So the cotangent of 0 is going to be the reciprocal, 1 over 0. Well, 1 over 0, that's undefined. Okay, so everywhere that tangent is 0, you're going to end up with cotangent being undefined. Or everywhere tangent is 0, cotangent has an asymptote. So since tangent is 0 at 0, there's going to be an asymptote here. And then tangent is also 0 at pi, 2 pi, 3 pi, and so on. So at pi, 2 pi, 3 pi, and so on. Okay, you can also go you can go to the left. So at negative pi, at negative 2 pi, you have other asymptotes. Okay, so then your cotangent is going to cross in the middle of those asymptotes. So right in the middle, every time it's going to cross the x-axis. And instead of being an increasing function, when you plot points for cotangent, it's a decreasing function. So it starts high, comes in, ends low. Okay, so here's your sketch for cotangent. Okay, all right, and that's your cotangent. Then similarly to the tangent, again, the amplitude, it doesn't really matter. Okay, now it's gonna change kind of the steepness of the curve, but it really doesn't make a huge difference when you're sketching it in. So amplitude isn't really a concern, but that that value for A can kind of affect like how severe that curve is in the middle. Okay, and then let's talk about period. Okay, so your period for cotangent, just like period for tangent, is pi and then divided by b. So if there's a value right in front of your theta, then that's going to affect your period. C is that horizontal shift, and D gives you your vertical shift. Okay, so again, same as cosine and sine, you can shift these graphs up and down, you can shift them left and right. Okay, the main thing is finding your asymptotes. So B times theta minus C is equal to 0, and solve B times theta minus C equals pi. When you solve those, that will tell you where your asymptotes is. Now, again, if you know where your asymptotes are, then right in the middle of those asymptotes is going to be where your cotangent crosses the x-axis, and then you can just repeat that pattern on, and then just copy that same function. Okay, so that is tangent and cotangent. I'll have a second video that will